Okay, this video is going to work with something called mole fraction. It looks like an ugly little booger, but it's really not all that bad when you get down to it. I have these super ugly looking equations. This capital X stands for mole fraction. So it's just a generic equation because you can use these for any solution. X sub A stands for the mole fraction of A, and X sub B would stand for the mole fraction of B. Remember N from our gas law equations, PV equals nRT? This lowercase n stands for the number of moles. What it's telling me is that the mole fraction of A, I guess I should have done that as a lowercase a, will be the moles of A divided by the moles of A plus the moles of B. Quite like any fraction, what I'm doing is simply part over whole. So if I have a solution, like in my first example, that says ethylene glycol is added to automobile cooling systems, what's the mole fraction of each component in a solution that has 1.25 moles of ethylene glycol and 4 moles of water? Okay, well, the whole is the ethylene glycol and the water together. The parts are ethylene glycol and water. So I can figure out two fractions. I can figure out the fraction of ethylene glycol compared to the whole thing, or I can figure out the fraction of water compared to the whole thing. So what I'm going to do is I'm going to do 1x for Eg. I'm going to put Eg for ethylene glycol, and I'm going to put XH2O. So the fraction of ethylene glycol is going to be the number of moles of ethylene glycol. Well, right here it says 1.25. 1.25 moles of Eg. And then my equation says to put it over both of them together. So that'll be 1.25 moles of the one of them and 4.00 moles of the other. So if I do my math, that's going to be 1.25 divided by 5.25. My mole fraction is 0.238. I decided to give it with 3 sig figs since everything going into it had 3 sig figs. There's not a unit, it's just a fraction. It's 0.238 parts ethylene glycol. Okay, so if I do it for the water, then it's going to be 4 on top because there's 4 moles of water, and the bottom is going to be exactly the same because it's still a solution that has 1.25 moles of ethylene glycol and 4 moles of water. So now I've got 4 divided by 5.25, and I'll get 0.762. Now, if you're a good thinking person here and have a good deal of common sense, you might figure out already that the two of those as fractions, if it's parts over whole, should add up to equal the whole, which would be 1. And, you know, if you think about it, 0.238 and 0.762, that seems to check out. They would add up to equal 1. So that tells me I probably did it right. We're going to try another one. This one is not so friendly. And the reason it's not so friendly is because it doesn't give me moles. Just because of that, I'm going to come on down one more, so I've got plenty of room to work. I don't have to start out with moles because I know how to convert grams to moles at this point in my chemistry career, gosh darn it. So if I have 50 grams of carbon tetrachloride and 50 grams of chloroform, then the very first thing I'm going to have to do is I'm going to have to do some mole conversions to get this to be moles. So carbon tetrachloride is CCl4. Well, if you do a little calculating there, that's 35.5 times 4 plus 12. So this will have a mass of 154.0 grams per mole. And then I'm going to have to do this again for the chloroform. It's 50.0 grams of chloroform. And they give me the equation, or the formula, I'm sorry, thank goodness, so that I know what it is. It's CHCl3. So this time that'll be 35.5 times 3. That'll be added to 1 plus 12. That one is 119.5 grams. So do some calculations. 50 divided by 154. This one is 0.32. I'm going to round it to 3 sig figs, even though I shouldn't. for the sake of working this out. It'll be that many moles of CCl4. And I've got 50 divided by 119.5. That comes out to be 0.418 moles of CHCl3. Now, if you were listening to me earlier and I told you that things should add up to equal 1, not yet. I don't have any mole fractions yet. All I did was convert grams to moles. Now, I'm ready to find the mole fraction of CCl4. So I want to know how much CCl4 there is compared to the whole thing. Well, that'll be 0.325 moles over 0.325 plus 0.418. Don't forget about parentheses in your problems if you want this to end up being correct. That'll equal 0.437. And then the fraction of the CHCl3 is going to be 0.418 moles over 0.325 plus 0.418. Now, this is the place where I should add up to equal 1 and 0.623. So it is 0.437 carbon tetrachloride and 0.536 parts chloroform. And those two numbers do add up to equal